Hi, and welcome to Higher Order Polynomials Day 1. Today we are going to do factor by grouping. Some of you have seen it before, some of you have not. So it's kind of a review for some of you, and some of you will be brand new. So to factor a polynomial means to express as a product, and this can be done when all the terms share a common factor. So for number 1, we have just looking for a GCF, and 4a cubed b squared minus 8a squared b squared plus 12ab, my GCF is 4ab. And I can factor, once I factor that out, divide, I will have a squared b minus 2ab plus 3. For number 2, I have negative 6x to the fourth y plus 15x cubed y minus 3x squared y. My GCF this time is going to be negative, and it's going to be a negative 3x squared y. And I'll be left with 2x squared minus 5x plus 1. So that's just finding a GCF, which we already know how to do. For number 3, when you look at this one, I've already done part of the factoring. If you notice, 3x minus 4y and 3x minus 4y is inside both of my parentheses. This is now my GCF. My GCF is a binomial. So my GCF is 3x minus 4y. And then when I factor out both of those, I'm left with 2x plus 5y. For number 4, again, my parentheses match, a squared plus 3a plus 1, and that is my GCF. And when I factor that out, I'm left with a minus 2. For number 5, again, my parentheses are still the same, 2m plus 5. And I'm left with x squared minus 3x minus 10. Now that looks like something we can actually factor again, and we need to look to see if we can do that. And there are factors of 10 that subtract to give me 3. So 2m plus 5 stays as it is, and this one becomes x minus 5 and x plus 2. Now for number 6, I don't have anything factored for you. So when we group, I have 4 terms. I group the first 2, group the second 2. In the first 2, I have a GCF of A, and I'm left with x plus y. In the second 2, I have a GCF of B, and then I factored that out. I'm left with x plus y. Now you can see that they both have an x plus y, so that becomes my new GCF, and I'm left with A plus B. For number 7, again, factor, group them first. So in my first set of parentheses, my GCF is 2x, and then I'm left with 3x plus y, and in my second set, my GCF is minus 5, so I'm left with 3x plus y. When I divide by negative, that changes that negative to a positive. And my goal is always to get my parentheses to match, and they do. They're both 3x plus y. And I'm left with 2x minus 5. For number 8, I got to do the same thing. Group and group. And my GCF there is 6mn, and I'm left with m minus 2n. And my GCF here is negative 10m, and I'm left with negative 2n plus m. So 6mn and then m minus 2n minus 10m. And I'm just going to reorder that to m minus 2n. Now you can see my parentheses match, so my GCF is m minus 2n. And then I'm left with 6mn minus 10m. However, if I look in here, the 6mn minus 10m, I still have it's still factorable. I have a GCF in there, and that GCF is 2n. And when I'm done with that, I have 3m minus 5. And then just to clean things up to write it neatly, I'm going to pull out my single GCF out in front. So it's 2n, m minus 2n, and 3m minus 5. On my last one, I'm going to group again and group again. And my GCF here with the 60x to the fourth y plus 36x cubed y squared would be 12 x cubed y. And after I factor that out, I'm left with 5x plus 3y. Here I'm going to have a negative 3xy cubed for my GCF. When I'm done, I have 5x plus 3y. Now both my parentheses are the same, so that becomes my GCF. So 5x plus 3y. And I'm left with 12x cubed y minus 3xy cubed. And that is factorable. There's a GCF in there of a 3xy. So 3xy is my GCF. And after I factor that out, I'm left with 4x squared minus y squared, which, if you look closely, is a difference of two perfect squares. So we have 5x plus 3y and 3xy, and this becomes 2x plus y and a 2x minus y. Now just to clean it up, I will bring my single GCF out in front, so 3xy, and then I have 5x plus 3y times 2x plus y times 2x minus y. And that is factoring by grouping. That's a little bit different than what we did earlier in the year with factor by grouping, but it's still another way of factor by grouping. We use this when we have 4 terms. This type of factor by grouping when we have at least 4 terms.